Is my screen visible? Can somebody quickly say yes or no?
Yes, ma'am.
Yes.
So it is visible in full screen mode, right? Is the screen visible in full screen mode?
Ma'am, it's not in full screen.
Yes, ma'am. Yes, ma'am.
Okay, excellent, excellent.
It's
So,
not full screen, ma'am.
sorry,
Not full screen, ma'am.
it's not full screen because I can see
No,
a
ma'am.
full
It is
screen.
full screen
Yes,
now.
yes, ma'am. Full screen, full screen.
Visible, ma'am.
Due to
Okay.
internet connectivity is delay, na?
Okay, okay. So, good evening, all of you. I'm Dr. Kalpana Gupta. I'm Scientist F and Associate Director with Center for Development of Advanced Computing. It is a scientific society under Ministry of Electronics and Information Technology. And today I'll talk about fundamentals of machine learning and how to apply machine learning using Python. I'm sure all of you must be aware of to some extent what is machine learning, but can anyone actually say what happens during the process of learning? What exactly happens? Anyone can give the answer on this? Or anybody would like to give the answer on this? What happens during learning? When we train a machine model, what exactly we train? What exactly we are trying to what exactly we are trying to do with the machine so that it learns?
From data
We
to
train the
some.
data.
Sorry, one at a time, please.
Ma'am, we are
Hello,
giving some
Kalpana.
preset data,
Hmm.
which is the training data, along with the labels in which we
Hmm.
want to and make the machine learn, so that if some features belong to a particular category, the machine learns it, and in future, if we give the testing data, the machine can predict the labels.
Actually, again, the question is you have told the process. Okay, you will tell some data, and then you will tell, okay, what is this? Is it an apple? It is not an apple, right? Okay. And then the machine will understand ki, okay, but what is that understanding? What happens in what is it that is something internal to the understanding of machine? When we
From
say
data
ki
to
machine,
give the
yes,
rules, ma'am. From
sorry,
data to it generate the rules. From data to it generates
rules.
some rules based on the rules.
Rules. Okay, actually, that is where is different. We are doing machine learning. We are not developing. We are actually developing a machine model through machine learning. We are not developing a model using rule-based system, right? Rule-based system is another way of making a system intelligent in artificial intelligence, that subject. But machine model or making a machine intelligent is a different way altogether. So there is no rule-based system over here. We actually do not develop rules in this, right? Rule-based system is entirely different thing. So machine neither develops rule in this case when we are talking of ML. So what exactly happens when machine learns? So let me tell you, let's say there is a small child and teacher is trying to teach him, teacher is showing them alphabet A and teacher tells this is A, right? Then teacher again writes A with her hand and then teacher again tells this is A again. So various ways in different formats A is written, this is capital A, this is small a, this is A is here, then A can be written in a cursive way also, and so on. And the child understands that this symbol, which is drawn using three curved lines, straight lines, is an alphabet A. And then teacher tries to test him that, oh, what I have told is this, whether the child has been able to understand this is A or not. Teacher will show multiple alphabets to the child and ask him to pick up what is A. Okay. But this is what is happening in the process of learning. But what changes learning brings to the to the brain of the child? Or kya ho jata hai? What exactly happens? So actually what we say is, it is the training of the weight that happens during the process of learning, right? So one is, child has to extract out, because an image is shown to the child and child tries to extract out the features from the image which is being shown, and out of those features, now suppose, I'll again come back to, suppose child learns this is A, and if teacher draws a symbol like just upside down V character, yeah, V for van, and then teacher asks, is this A? What do you think child will say? I hope you are getting what I am trying to explain. Teacher is teaching alphabet A, and child has learnt it to some extent. Teacher has shown few variations of A, and now teacher is showing him V, which has been put upside down, right? What do you think child will say?
Sometimes it may say correct, sometimes it may be wrong. It may
Why do
be
you think
confused.
you might be correct to it? Isn't it? But is it correct? First of all, let's see, is it correct?
It is wrong.
It is wrong, right now? है ना? But why do you think child will say yes to it?
Because
Yes, yes, please.
it is in the learning stage.
It is in the learning stage, or should I say, the importance, what importance the child should give to which feature of the alphabet is still not very clear to him. Is it clear? Yes or no?
Yes, ma'am.
There are two lines meeting at an angle, and then there is a horizontal line in between. It is an essential feature of alphabet A, right? And unless so that horizontal line which it missed, okay, has some importance. And
Kalpana
that,
ma'am,
yes,
ma'am, are you changing the slide? I
no,
mean, it
no,
is
no,
only
no,
the title
no.
slide.
Right now I am not. Right now I am not.
Okay, okay, ma'am.
Okay. So, if what is very important for the child is that he should understand that one slant line, another slant line, and a horizontal line in between. All three are important for making the alphabet A. And if there is any one of the line which is missing, then probably that character will not be called as alphabet A, right? And so it has to give importance, and that importance is what we call as weights. Okay, so weights training is actually what we call as machine learning. Simple. That is what is model training, or training the machine, or machine learning. How good the machine has learned is how clear the weights have been decided by the machine, and that is what we are going to talk about today. Okay, so what is machine learning? It is obviously the branch of AI. People generally have doubt, is AI the branch of ML, or ML is the branch of AI? Obviously, AI is a very, very big domain, to be very frank, and machine learning is a small part of it. And rule-based systems is a part of AI. Again, rule-based system, making the machine intelligent using rules, or writing rules as we do in Prolog language. Okay, using Prolog is quite common. It was very, very common during the initial phases of AI, or making the machine intelligent. But because of availability of lot of data, things have become quite simpler, and now we use machine learning very, very often. So it is, this ML is focused on building systems that learn from and adapt to data. So if there is no data, we cannot use ML. Simple. Okay. If there are no multiple alphabets A written, child cannot learn A. Okay. And without being explicitly programmed. Without being explicitly programmed means like teacher draws A. Teacher never says, look, I have drawn one line um, which is at an angle of 60 degrees with the x-axis. I have drawn another line which is at the 100 angle with the x-axis, and there is another line third joining the two lines parallel to this, and so on. Teacher doesn't say that, isn't it? They are just simply showing the images, and a child is learning out of it. Similarly, if you have any other type of data, uh, uh, um, obviously, see, let's take one example. Suppose these social media sites want to actually put a check on who is accessing. So they want to debar the children below the age of 13 to join their social media platform. How do you think they can do? Because child can use all sort of measures to tell that he is above 18, or he might be 10 actually, right? So what do you think social media can do in this case? Can they really stop the child from joining social media platform if he or she is not eligible to join as per his age? What do you think? Anyone?
Yes, Kalpana ma'am, I can explain this.
Okay.
These days we have an application of speech therapy, like we can detect the age from the voice of the person. So
Okay.
this application can help us to determine the exact age, although he can use all the efforts to telling us that he is above 18, but the voice can tell us that what is the correct age of the person.
Can voice actually tell the correct age of a person?
And it is another application of machine learning and deep learning. So at some extent, yes, it is helpful for us for determining.
Okay. Okay. Uh, right. Can there be other ways also? Because what will happen in this scenario? How system can be fooled? Let me tell you that. Okay. What will happen is child will try to mimic the voice of the elder one. That is one way. Okay. Child may become friend with some elder fellow, and then elder fellow may help him join the social media site. That is also possible. So these possibilities are definitely there. Now, this is one way that, okay, child never able to join the social media platform. Another way is, even if a child below the legible age is joins the social media platform, his behavior might actually tell that he is a child below the age of 13 or below the age of 16, and probably depending upon the behavior, depending upon the choices that he is making, it will very clearly tell that what age he is telling is wrong. Right? Sorry? Please ensure that your microphones are on mute. All of you, please ensure that your microphones are on mute. So without being explicitly programmed, you're not exactly telling each and everything to the system. Okay. A system is automatically identifying the pattern. System is automatically trying to figure out what is it is important and what is it that is not important. So I should assign higher weights to something, to some features which are extremely important, and lower weight to those features which are less important. And this tuning of the weights, when it happens correctly, obviously there is nothing like what we call as correctly, but to higher accuracy, when the weights are freezed, we say that the machine has actually learned. Okay. So again, the point is, it is not being explicitly programmed to see. We are not telling the machine, okay, look at this feature, assign this weight to this feature. Automatically, it is doing it. Okay. So what ML allows computer to learn from example. This is extremely important. So machine becomes intelligent because machine is allowed to learn from examples. So ML is one form of learn by example. Another form is rote learning. Okay, you just cram up, like if you remember, Deep Blue was meant to play chess and was able to defeat I think Gary Kasparov in playing chess, but that was not actually intelligent machine. That was rote learned machine that had huge memory, huge processing capacity, and it was not thinking at all. It was seeing the state and figure out the next state it should move. Sorry. So ML allows computers to learn from examples. And once they learn from few examples, they are able to generalize and handle new situations effectively. So it is not that once the machine has learned on, let's say, 10 examples, when some 11th case comes up, the machine should be able to generalize on the example using which it has learned. So this is the crux of ML. Very important. There have to be three types of data: training data, validation data, and test data. Now, training data is, let's again take the example of a teacher teaching a child that it is alphabet A. Okay. Or let's take another example, because that will be better in this case. Suppose teacher wants to tell a child this is an apple. Okay, so first teacher shows, again, this is a very interesting example. Okay. Teacher shows a picture of an apple and tells a child this is an apple. Okay. Just a picture is shown and child does, okay, this is an apple, this is an apple, this is an apple. Different types of pictures of apple are shown to a child and child learns it is an apple, right? Now, teacher takes this child to principal, and principal will try and validate whether the child has learned. Teacher will say, now child can tell this is an apple. Okay. Now, teacher, the principal actually shows the physical apple. Instead of image of an apple, teacher says, okay, pick up an apple. Where is an apple? Now child is looking here and there. What do you think will be a child? Sorry? Do you think? Hello? Do you think child will be able to pick up a 3D apple, actual physical apple? A child has been shown pictures of apple. Teacher has told him this is an apple, this is an apple, this is an apple. Different pictures of apple were there, and child has learned. Child goes to principal. Okay, teacher is very happy. Child has learned apple, to identify apple. Principal asks the child to identify the apple amongst the fruit basket. Do you think child will be able to understand which is an apple? And assuming child has never seen apple in his life, maybe of 2 years or 3 years, do you think child will be able to pick up an apple from a fruit basket?
No.
Why do you think no? Why no?
Because he has never experienced to
He's
hold an
never
apple.
experienced, he has never seen a three-dimensional apple. He has just seen an image of an apple which is in 2D. That's it. Okay. Now, according to him, he has never understood that apple is a physical thing. According to him, now he might have learned that a page on which some red color circular shape is there, this complete page is an apple. Is it clear? teacher has been showing him a page. This is an apple, this is an apple, this is an apple, this is an apple. So there is an A4 sheet on which apple is printed. Okay. So when the child is looking at this A4 sheet, okay, understand from this, from machine perspective also. Okay. So there is a complete page and child is looking at it. This is an apple. So according to him, a red color circular figure drawn on a page of A4 size is an apple. Right? But it is actually the physical thing which is an apple. Okay. There are various aspects associated with an apple. What teacher was showing child was a picture of an apple on an A4 page. It could be a sketch of an apple, pencil sketch of an apple, pen sketch of an apple on an A4 page. That's it. Right? So, what is an apple out of that, out of what he is seeing on the page is extremely important. So, his understanding needs to be fine-tuned. So, there is a training data, there is a validation data, and there is a test data. So, you have complete data which is available to you, and then you divide that data. Let's say 60% you keep for training, 10% for validation, and let's say 20% later on for testing the model. Now, what does it mean? It means suppose teacher has, let's say, 10 ways, 10 cards on which alphabet A is written and teacher is showing it. Okay, so teacher tells this is A, this is A, this is A, and then it after 4 or 5 cards, teacher stops. Let me check, let me validate what child has learned. So that is actually the validation data. It is used to tune the model parameters. Fine tune whether it is understanding or not. Or do I need to explain more features related to the alphabet A? And test data is once the machine has been trained, now you want to check how good is my model, how accurate is my model. That is what we do using test data. I hope training data, validation data, test data is quite clear to all, because generally we end up splitting the data, dividing the data into trained data and test data. But there is keeping validation data is actually a good choice when you are trying to train the machine. Is it clear? Anybody having any queries on this? Shall we proceed? So, how ML works? Okay. So, one is you require the input data, lot of data, not some data, but lot of data is required. And then the system has to extract features out of it. So, the system has to figure out what, sorry?
Ma'am, can you make the screen is full screen? Because just also the screen is showing.
Your voice is not clear. Your voice is cracking in between.
Okay, ma'am, could you please check the full screen, ma'am?
Sorry, you are not audible at all. Am I audible to all? And is my screen full screen visible?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
I think somebody was having some problem. See, there's absolutely no issues at my end. Please check the connectivity at your end. Okay. So first of all, you require a lot of data. Then there has to be some ways by which feature extraction should happen. So key attribute or features of data are identified. Now it depends purely on what type of data you are working with. Is it the numbers you are working with? Is it the textual data you are working with? Or is it the images that you are working with? Is it the videos you are working with? So what kind of data you are working with will decide what kind of features are there. Okay. For some of the machine learning algorithms, it is very important you categorize the features. You should tell these are the features in the data. For an example, if there is a data related to housing price, that means you want to train a machine model which is able to predict the price of houses uh, um, in certain locations in cities. Okay, so you will tell where it is located, what is the size, what is the number of rooms, how old is the construction, is it the flat or is it the complete house on the ground, right? So there can be multiple features. Okay, so these are explicit features which have been given in the data. While in case of an image, uh, suppose you are showing multiple images and the problem is to identify a monkey in that image. Okay, now in this case you are just telling in this image monkey is there and in this image monkey is not there. That means you are labeling it. That's it. You do not the color, the texture, the shape, none of the feature you are explicitly telling. Okay, but it is not necessary that you do not tell. You may tell in images also. You can actually tell the color or texture or the shape. These kind of features you can tell, but generally the algorithms which are there for image for working on image based data are quite capable of extracting these features. Okay. So therefore those datas which uh, uh, do not have numbers. So there are different algorithms which work on numeric data or structured data, and there are different types of algorithm which work on images or video files or audio files. So depending upon the type of data, your algorithm to train the machine will differ. Am I clear on that? Yes. First,
Yes, sir.
okay. So first you have data, then you have another thing which is feature extraction. You need to understand the data. So unless you look into the data, you will never be able to make it out ki what kind of machine model I should apply. Next is model selection. This model selection is nothing but which algorithm is suitable for training the machine. Okay. So is it linear regression? Is it the decision trees? Is it the neural networks? Is it RNN? Is it DN? So what kind of algorithm I should use, or I should use k-mean? What approach I should apply will be decided on the basis of the data. Okay. So all these are linear regression, logistic regression, decision trees, random forest. All of them are different ways of training the machine. And when we say training the machine, it is nothing but figuring out the correct weights for your data. Okay. So then key features, then is model selection. Then once the model has been selected, you start training the data. That means to the model, you will start giving data as an input to find patterns and relationship. Okay, so the model over here, okay, whichever you are choosing, like when we say logistic regression or linear regression, it is like a straight line, ax plus by equal ax plus by plus c equals to something. Okay, so this kind of relation, so a, b and c are actually the weights. Okay, in linear regression these weights are actually decided. So algorithm processes the training data to find the patterns and relationship. Remember, always remember that if your model is capable of handling structured data, it is capable of handling only and only structured data. If you think you would like to give some images to it, that is actually not possible. Okay. In fact, if you have designed a machine model and you have used algorithm which is working on image of 24 cross 24, then and if you try to give an input of an image which is, let's say, 25 cross 25, it will not work. It will not accept that. So there is a very, very important step when you work with is cleaning of data, pre-processing of data is an extremely important step. Rescaling or resizing of images is an extremely important step when you are working with machine learning. Okay. So let's proceed. So what you have the data, you have feature extraction, you have model selection, you have training, you have trained, and now you, once the model has been trained, it is ready for prediction. Okay. So what you are trying to do is you are trying to when a machine model is used for prediction, so like it will predict the price of house, it will predict the price of gold tomorrow, it may predict the price of shares, it may predict the AQI of Delhi tomorrow, and so on. Okay. Or it may classify whether a mail is a spam or not, whether the image contains monkey or not. Okay. So all of them are primarily machine learning based thing. None of them is generative AI because nothing is getting generated in this. Okay. But if you want to train a machine so that it is able to, let's say, um, um, in a network, it is able to generate a route for a message to reach from source to the destination. So you are trying to, you are designing a machine which is capable of generating the route for the message to follow in a given network. That is generative AI. Okay, generating something. Okay. So you have predicted, you have used them, and now is the time to evaluate whether the prediction has been correct or not. Okay, images were shown to the machine model, images were given as an input to the machine model, and a machine model was supposed to figure out whether the monkey was there in an image or not. Okay, so it will predict. It may say monkey is there when it is not there. It may say monkey is not there when it is actually there. Okay, so prediction made by the machine model might be correct or might be incorrect also. So it is extremely important that once the prediction has been made, it has to be evaluated. Okay, how accurate is the model? How many false positive are there? How many false negatives are there? How many true positive and true negatives are there? Right. So at times, uh, in some of the cases, we do not want at all, we do not want false positive to happen. Suppose we are designing a firewall for an organization. Okay. And that organization is, let's say, NTRO. Now these organizations are very, very sensitive in terms of security of the country, and the firewall is supposed to restrict any packet coming from outside the organization, and if it sounds suspicious, the firewall is supposed to stop that packet from getting into the organization's network, right? That is what firewall is supposed to do. Now in this case, there are possibilities that a packet which is not dangerous at all, firewall might stop that packet also from entering into the organization's network, right? And it may so happen this firewall will be quite capable of stopping any packet which sounds malicious from getting into the office network. Now what will happen is, for this machine model, true positive means which is not malicious. You may take whatever you want it in this way. Now if a packet is malicious, the machine should definitely be able to stop it. And if it may so happen now putting that boundary very high that none of the malicious packets should be able to get into the network. It may happen that some non-malicious packet may be identified by the machine as malicious and might not get entry into the machine network, but that is okay because that is the design choice, right? Uh, Now when you are training a machine to detect cancer in a person, in an individual, what do you want? Again, there are two possibilities. Person might be suffering from cancer and machine model might say no, he is healthy, he is not suffering from cancer and no further tests are required. Or a person is not suffering from cancer and machine might say there is a suspicion of cancer in this particular patient and should go for higher test. Okay. Now what do you want in this case? Obviously you do not want a person with cancer to go undetected, although it is a possibility that a person who is not having cancer, the machine might say that the person is having cancer when he is not having one. Okay, that is a possibility. But then higher test may actually help in turning down the incorrect option generated by the trained machine. So there is always a trade-off. What is it that you want higher? Okay, you never want false positive, or you never want false negative. So all this is a trade-off. Okay, and on the basis of these four things, true positive, true negative, false positive, false negative, you actually evaluate the model. Now once the model has been trained on, let's say I have trained a model which is capable of telling whether the input image has monkey or not. Okay, and I have, let's say, 1000 images, and using these 1000 images I have trained a model. Now my model is ready with me. Now somebody gives me 5 more pictures of monkeys that he or she has captured at some other place from some another location. Okay. uh, my model will be tested on those 5 images also. Now these 5 images are not from the original data set. Okay. Original data set is the 1000 data set of 1000 images which has been used to train the machine. These 5 images are separate from the database, and if my model is able to clearly classify whether the image has monkey or not, okay, then my model is actually correct, is accurate and reliable also. Okay. But generally when we present the accuracy of our model, we simply do it on the test data. Okay. Remember, the two things are quite different. आपके पास you had one data set of, let's say, 1000 images, and out of those 1000 images you train the machine on 7000 images, and you kept 700 images, and you kept 300 images for testing the accuracy of the model. Remember, the point over here is these images are of which 700 images will be used for training the machine, and which 300 images will be used for testing the machine is from the same pool, and images are picked up randomly. Okay, and these 1000 images or 700 images, there will be multiple epochs. Machine will be trained on those 1000 images multiple number of times till it is able to figure out the most optimized, most appropriate weights. Okay, so keeping those 300 images for testing the machine model is different thing, and testing the machine, evaluating the accuracy and reliability of machine on using a separate images which machine has never seen is actually a different ball game. You might get very high accuracy on the test data, that is the data which is the part of the original data set. Okay, and you might get very low accuracy when you pick up some random data and then you test your machine. I hope this point is clear to all of you. Yes?
Ma'am, what about validation data, ma'am, from 1,000
Validation data,
records?
see, validation data is, I give you an example now. Teacher is teaching in class, okay? And in between, teacher asks the question, right? That in between questions that are being asked, what is teacher trying to do? Teacher is trying to validate the learning process in the child, right? To intermediately to tune the parameters. See, what is validation data? Used to tune model parameters. And test data is used to evaluate model's performance. Once the machine has been trained, now you just want to say, okay, what is the accuracy of my machine? You will use test data. But training data and validation data is being used during the process of training only. Is it clear?
Ma'am, from the 700 image, I have to separate for some images for validation or?
Exactly. Yes, yes. The system will do it automatically, but yes, some of the images are for validation. Okay?
Okay, ma'am. Okay, then okay.
You can have 80% and 20% also, right?
Okay,
So
ma'am.
you put 80% for training and validation and 20% for test data.
20 for testing. Testing.
Yes, yes, yes. But validation is happening during the process of learning, and testing is being done after the learning has been done. Now you see, once the learning has been done, now you see, oh, the accuracy is not good. So what you will do, you will try and choose a different model, right?
Yes,
So
ma'am. Yes.
multiple things will be applied in order to get a higher accuracy. Okay. So models accuracy and reliability are tested using unseen data. Very, very important. And then you find out, you come to know, oh, the accuracy is very, very poor. Let me tell you one example. We were trying to build up a digital twin of a fan. Okay. And the aim was, we during this process, we trained a machine model which used to take an image of a pedestal fan, and if it is working, if it is in on state, fan is in on state, it used to say on. Otherwise, if it is in off state, it used to say off. Now we captured the video of a fan for a long time, and then we cut it into frames. That video was cut into frames, and we trained the machine model. Simple. Initially, uh, 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 we were getting on the given data, we were getting excellent accuracy. Okay, but when somebody was standing, that fan was the direction of that fan was turned, and the background of the fan got changed. Somebody else came behind the fan, and the background for the fan changed. The accuracy dipped drastically. It was not able to identify. So we were able to figure out that probably it is not able to distinguish that this is the background, this is the fan. What is it? It is picking up. Obviously, there is nothing like fan. It is only picking up the pixel values. That's it. Okay, but we understood that somewhere when the background is changing, it is not being able to pick up. So it is very important that for different backgrounds, fans with different background have to be given as an input to make it understand that what is the image of moving fan, or fan being in switched on state and fan being in switched off state. Okay, so what happened is we trained once, and we found accuracy on the trained data was very good, but when was evaluated, it fell down drastically. So we have to improve. We added more data. Now, what more data shall we add? It's not that I keep on adding the same data again and again. I have to think where my model is not behaving properly, where my model is giving an incorrect answer to me. It is very important for me to understand that. Okay. And though the model itself might not tell anything to you, but by figuring out on which type of data my model is giving incorrect answer, I should be able to choose, I should be able to add more data to it in that manner. Or it may so happen that I might have to adjust parameters, the initial value that I am picking up, the initial weights that we are picking up. We need to adjust those parameters also. We might have to adjust some hyperparameters. We'll come to those things later on. But these two are, at times it may so happen that by adding more data also, your model might not work good. So what we generally do, we might choose a different algorithm. Like we were doing, we were simply using a artificial neural network for those images, but it was not working. Simply shifting to support vector machine, it worked. Similarly, for this monkey problem also, identifying whether monkey is there in an image or not. For this problem also, we started with support vector machine, but finding it out that support vector machine became very slow when the database became large. So we have to shift to a CNN model in that case. So you have to actually use multiple variations, multiple different ways. Now, is it the CNN model from the sketch that you are going to use, or you are going to use transfer learning, some ready-made model you are going to use, and then you are going to further train that ready-made model with your data. All those techniques you have to use while doing machine learning. Okay, it's not that you pick up one model, you have one data you picked up, you have a machine model, the one that you applied it out, and then you got some answer. That way, machine learning models will not work. You will get poor accuracy also, or you might get some answer which is quite accurate on your data, but when it goes out, it's like a child performing excellently well in internal exams, and when there are board exams, child is performing horribly bad. Okay, so it is very important that the learning of the model should be right. Okay, so shall we proceed? So far, so good. Are we on the same page? Yes.
Yes, ma'am. Yes, ma'am.
Okay. So now we move on to, that was the general procedure of learning. Simple. Data, feature extraction, model selection, training, prediction, evaluation. And now we come to types of machine learning. One is obviously, which type should I use depends upon the problem at my hand. Okay? So one is supervised learning. Model learns from labeled data. You actually have input-output pairs. So when you are actually training the machine, and if you are training it for, let's say, classification of whether the image contains monkeys or not, so you need to have model in terms of pair. Let me show you something if I can. Documents data set. Is my screen visible? No.
Yes, ma'am.
Can you see dataset folder over here?
Yes, ma'am. Visible.
Okay. So you can see test directory, monkeys and no monkeys. Is it visible or should I enlarge it? I don't
Yes,
think
ma'am. It's visible, ma'am.
So monkeys is containing all the images which contains monkey, right? Now see in this image, none of the monkey is clear, but still the image was able to figure out there are monkeys. I don't know how, to be very fair. That is what explainable AI is. Okay. Again, in this case, it was able to figure out. And there were few images where um, over here it was able to figure out. And then somebody gave me few other images. And see, this is a different background. So taking all the images from one video was actually not a good idea. You have to have images. Again, differentiating between a dog and the monkey was very, very important. Differentiating between a monkey and a child was very important. So thinking from this perspective was very important for making the classification. And actually the problem was what we were trying to do with this classification of monkey. We were trying to build up an application to scare the monkeys. There is at places of worship, there are lot many monkeys in Gurgaon, in Delhi. There is actually monkey menace is everywhere. Okay, so we were trying to design a gibbon, what we call as langur. Monkeys are quite afraid of langur, so exactly look alike model of gibbon monkey, who will be having some cameras fitted inside it, and a microprocessor will be there inside that monkey. And through those cameras, monkey will capture, will scan its surrounding. And as soon as some monkey comes in its surrounding, the image will be captured. Image monkeys that given model is capturing the images of the surrounding. And as soon as there is monkey seen in that surrounding, the image will get monkey, and this model will classify whether the image has monkey or not. If the monkey is seen in one of the image, the microprocessor will process it and will generate different sounds of firecrackers, fight of monkeys fighting with gibbons, and all those things. Okay, so this is one way of developing the solution for handling the monkey menace. But to be very frank, though we trained this machine model was working very, very fine, but I still have doubts that monkey, which is actually an animal, will initially might be afraid of that given model, but later on might understand that this gibbon is just a model, not the actual langur. And after some time, monkey will stop getting afraid of that model gibbon. I don't know how you feel like, what is your opinion on it, but that is what is my opinion. Unless that gibbon is able to have some motion, also is able to move its tail, is able to move its neck, obviously some more changes have to be done in that. Okay, then only it will be of some use. But in the given state, I have my doubts it will be able to actually afraid anyone. Okay, so let's proceed. So what you can see is in this data set, uh, what I was trying to show is test directory, monkeys and no monkeys. So this monkeys and no monkeys is actually telling which is labeled as what. Okay, so monkeys, this folder is telling that this contains the images with all the monkeys, and no monkey shows the images which do not contains monkeys, right? So supervised learning is a type of training where you have the labeled data. Now, it is not that you explicitly label each and every data, but there should be some way of figuring out what is the label of this given data. So the machine model is able to map the input to output quite accurately. This kind of supervised learning is used for predicting the house prices, or classifying emails as spam or not spam, or classifying other images like this, whether there is monkey in the image or not, and so on. Okay. Another way is okay, the popular algorithms used in supervised learning, linear regression, logistic SVM, all kind of neural networks by far are used in supervised learning. Then there is unsupervised learning. Now, in unsupervised learning, actually, it is not for classification, but it is this unsupervised learning is used for finding the patterns or the structures. Okay. So it is something like if we use clustering and we have lot many images bundled up together, there are no labels. That means if we merge the images with monkeys with images which do not have monkeys, what do you think might happen if we use clustering? If we use unsupervised learning, it will able to classify, it will able to generate two different regions where in one region it might put the images where it find monkeys, and in another section it might put all the images which do not, but it will never have any understanding, to be very frank. Okay, it will, according to the patterns that it will see in the images, it will try and cluster them into two different sections. So that is what is unsupervised learning. Okay, so the use is customer. If I want to segment the customer, which customer are repeated customer, which have the return value, so I might target more on them. So all these things are this unsupervised learning is useful in that case. Similarly, what genes will have similar expression? Genes are responsible for generating the protein. So clustering of genes is another application of unsupervised learning, right? So you have supervised learning. The algorithms that are used is principal PCA is very common. K means clustering, density based spatial clustering. All these are a different type of clustering only. Okay. So hierarchical clustering is very common. So different algorithms for different ways. Then semi-supervised learning, which uses both. Now, suppose if I have a mixed bundle of images, okay, now how to segregate them? Suppose I have 10,000 images. In some of the images there are monkeys, some of the images there are no monkeys. How do I manage that? How do I handle that? So I'll use semi-supervised learning, or which uses best of both the world, unsupervised as well as supervised. Okay, so combines labeled and unlabeled data. Your data might be labeled, your data might be unlabeled, and leverages unlabeled data to improve the learning. Okay, so you have the labeled data, and it will use that unlabeled data to improve the complete learning process. That's what we were doing when we were talking of evaluation. Speech recognition uses this kind of semi-supervised learning. Okay. You can have partially labeled audio clips, and you can have totally unlabeled audio clips, and so on. Reinforcement learning is in which there are lot many sensors are available. The system is sensing the environment, receiving. Now, depending upon the learning, depending upon how it is interacting with the environment, how the system is interacting with the environment, it will receive rewards or the penalties. Like we use this type of technique in unmanned systems. Okay, making the robo walk, or making autonomous cars. Reinforcement learning is very important. Similarly, in game playing also, reinforcement learning is very common. Okay, if you are rewarded, you think, you come to know you have played well, and then you store it. If you are not rewarded, it tries to forget that. Okay, so that is what, although there are very complex algorithm for reinforcement learning, but it is a very effective way of learning. Q-learning, DQNs, they are quite common algorithms, but there are many. Many means actually many algorithms, and quite complex algorithms as well. Few of the applications of machine learning. It is used in healthcare, highly used in healthcare. In fact, you might have heard of disease diagnosis is using this. Okay, cancer detection from X-rays, no, personalized medicine recommendations. Okay, all these things are done using machine learning only. Okay. Also in drugs, which drug is fit for, which medicine is fit for which person, all these things can also be done using the machine learning approaches. Finance sector, fraud detection. predicting the prices of gold, predicting the prices of stock market analysis. Okay. Similarly, insurance companies are using machine learning. Okay. So, lot of application in finance. In detail, recommendation system, I'm sure all of you might have heard of these recommendation system. How good they are, you know it very well. Similarly, YouTube's recommending you the new videos. At times, it so happens that you get so fed up, you want to clean the history of YouTube so that it gets populated again and you are able to get some new videos. Similarly, price optimization uses is one of the application. Autonomous vehicles, path planning, object recognition, object detection, driver's behavior analysis, whether the driver is sleeping or not, detecting the driving pattern of a driver, and uh, predicting whether a driver is going to fall asleep or not, and accordingly generating the alarm so that driver do not sleep. That is a very common application. Similarly, uh, using the driving behavior system may predict whether the driver is drunk or not. Okay. So such kind of applications obviously have high importance. Similarly, your mobile phone might say it is not going to open this application because you are driving right now. So all these things are happening because of machine learning only. Yeah. Application of ML in NLP, language translation, sentiment analysis, on the fly speech to speech translation, cyber security. I have given you the example of intrusion detection, malware classification, spam mails classification. All these things are quite common in case of applications of machine learning. Okay. Now, what are the possible challenges? If you're trying to, it sounds very easy and good that, okay, machine models are there, you have the data, you train, and you use that machine for doing various things. But there are lot many challenges. First challenge is data quality. You try and solve any problem using machine learning, any problem. The first thing that you will face is, oh, there is no data, number one. Number two, you do not have sufficient data. Number three, if data is available, it is not in that form in which you require it. Okay. Then there might be lot of noise. If you find data, it might be having lot of noise. Okay. So according to the problem, it is very difficult to find data. For an example, if you want to work on a problem, let's say, um, detecting the text in the wild. Now, what is this problem detecting the text in the wild? Is uh, uh, you capture images randomly and then there are boards available. Remember, the difference is it is not OCR'd text. Okay, you have not used optical character recognition techniques to identify that text. Okay, you just have the images. Then, so you click the pictures in market, and then there are the name of the shops coming up in those images. Now, detecting the text from those images is quite challenging. Okay, so that problem is known as uh, um, um, detecting the text in the wild. That is the problem. So you require a lot of data. Okay, data has to be as per your requirement. High quality, relevant data in large volumes is actually very big challenge, because more the data, better will be your machine. More the variance in the data, more data that you have, which is captured from different areas, will be better for your machine learning. So one challenge is data quality. Another issue which you might face is that of overfitting. Now, what is overfitting? your data performs very well, your machine performs very well on the data using which it has been trained, while it performs very badly on the other data. That is what is overfitting. Okay. Model is just too good. It is giving 99% accuracy on the test data. But when some another data was given from different data set, performance has dropped down drastically. That is what is overfitting. Computational resource. I told you we tried doing something on SVM, but system did not support it. Okay. So computational resources is again, suppose you want to work on, let's say, 1 lakh images. You might get 1 lakh images, but you want to work on it simultaneously, it won't be possible. Okay. For your machine, there are very, very limited resources available. Okay. You have to buy those resources on cloud space or somewhere. So actually this machine learning, and then you have to keep it overnight. Okay, for 10,000 images, or let's say 5,000 images of monkey, we have to keep the machine on overnight so that it is able to generate some results. Okay. So that is only for 4,000-5,000 images. But if you have like 1 lakh images, because larger the data, better is the model training, the compute resource will be very, very high. Then there are ethical concerns. Because to capture the data, what you will do? You will click images right now. And clicking images is intruding into the privacy of someone else. Okay. Plus, there are possible biases in training data. It may so happen that a model has been trained, it is being used at the New York airport to figure out whether a person going through the security check uh, uh, is a criminal or not. Now, if there are biases in the data, like suppose the machine has been trained using the data of black criminals, criminals who are black people. Okay, the model has been trained using that data. Now, what do you think will happen at the New York airport? Your model will only figure out the black person as criminal, and even if there is a white person who is a criminal, will pass through the security check, whereas a black who is non-criminal might be detained, might be asked to go for further security checks. So that is the potential bias in the training data, and that is very common. Then the problem is transparency and interpretability. I told you the example of fan being switched on or switch off. Yeah, we were trying to figure out what is it that is not making the machine model give the correct answer, but what is it that is not allowing the trained machine to give the correct answer. So we just tried to figure it out. Okay, changing the background might be one of the reason. Again, might be one of the reason. Okay, it it could have been a reason, it could not have been a reason. Okay, so we can never be sure of our model. Okay, it is accurate. Okay, it is giving 99% accuracy. Okay, but whether for a given input image, it will give me the correct answer or not, I can't say. Okay. So also I do not know how to this machine model is not explaining me anything. If for a particular data, if for a particular person, the model says that person is going to suffer from cancer, okay, and I want to know why it is giving me this answer, machine will never be able to explain me that. And so that explanation is missing in current approaches being used in machine learning. So transparency and interpretability of models is actually missing right now. Okay, and it has to be looked into, and that is what is being handled in explainable AIs. So what is the way ahead in machine learning? uh, for the resources, obviously computational resources are required. So probably integration with quantum computing, accelerating the machine learning task using quantum algorithm is the things that are going to happen in near future. Explainable AIs to handle this problem of ethical concerns, transparency and interpretability of models will be handled by explainable AI, enhancing their transparency and trust by making models more interpretable. You should be able to interpret what it is trying to say. Then using the AI models on the edge devices, we were trying to work on drones and we were trying to fit a trained model on a drone. So we require some device, Jetson Nano. So we have a trained model on those edge devices. Okay. But if I want to use the edge devices for training purpose itself, then definitely there's still a long way to go. We may use edge devices like phones, smartphones, IoT devices, nodes, something like those also, or development boards for using the machine models. But if it comes to training, then edge devices need to be much more efficient. Though there are few development boards by NVIDIA like Jetson Nano, Xavier, they are like GPU boards, quite capable of training the machine. But when the data will become large, probably even these devices will not work. Okay, so that's the way ahead. Anyone having any queries so far? So I think I'll stop over here and then we'll move on to creating a neuron using Python, so that you will understand what I'm trying to explain. Anyone having any doubts, any queries in this session? Sorry? Your voice is not clear to me. Yes, you are audible, but it is cracking in between. Yes, please. Jagat, can you type your answer, please? Yes, sorry, can you type your question in the chat box?
Not working here.
Chat is not working.
You can write in Q&A section. Question and answer.
Thank you. Okay, sir.
Hello, ma'am.
Yes, Sangeeta.
Ma'am, validation process is optional or compulsory one, ma'am? Hello, ma'am.
Yeah, I got your question. Validation process is optional, right? I gave you the example also. If teacher is teaching in the class, fine, let the child face the test later on. But if teacher wants to know how much child is learning in between the process of teaching, then validation is important. It is a good choice to keep validation data and to use validations in between, but it is not necessary.
Validation data should have label or it should not have label, ma'am?
It should have labels. It should have labels.
Okay, thank you, ma'am.
Yes.
Thank you, ma'am.
Okay. Anyone else having any query? Anyone else? I think we can take a break and we'll start with the next session. It's 7:54. Shall we start the next session at 10 minutes past 8 or 15 minutes past 8?
Yeah, ma'am, no problem. You can.
Okay.
Ma'am, I have one question, ma'am.
Yes.
How should I know our model is good or not, ma'am?
how you should know your model is good or not, whether your model has been trained well or not, right?
Ma'am, suppose I am using some linear regression instead of SVM. How should I know this algorithm is not suitable for my data set? How should I know?
See. Okay. So
Hello.
on evaluating, you check the performance. Okay. Right now, you evaluate your model and check the performance. If the performance is very poor, what are the possible reasons for evaluate at the time of evaluation that the performance of the model is very poor? You have to figure out some reason, right? One is, if you're using very less data, performance will be poor. But if you are using large data and still the performance is very poor, then you have to think of what is the possible reason, right?
Okay, ma'am. But all are trial and error method, ma'am. Is it
No,
correct,
it's
ma'am?
not trial and error. Yes, first of all, you have to increase the data only. Second is you change the parameters, and third is you change the model. This is the sequence which is generally followed. Okay.
Okay, ma'am. Please repeat, ma'am. What are the 3 steps, ma'am? First
One is you check whether the data you are using is sufficient enough or not. Okay. If you're using very less data, then obviously it is possibly you are not getting the good results because of less data. Okay.
Okay, ma'am.
But if your data is very large, okay, it is like you are using huge data, then only 2 possibilities are left out. Either the initial parameters you are using is not right, or the model that you are using is not fit for the problem, right? So as far as problems are concerned, probably for this kind of problem, these kind of models generally work. Okay. But first thing is you should increase the data. Second is fine tune the parameters, change the initial parameters that you are using. Okay. And if these 2 things are not able to generate the good results for the model, then obviously change the model.
Okay, thank you.
Okay. So we'll start with the next session at 15 minutes past 8. Thank you so much.
Ma'am, one question, ma'am.
Excuse me, ma'am. Any feedback form will be shared, attendance form or something?
Attendance we will automatically download, and feedback form last day we will share.
Okay, so attendance is automatically it's recorded in the system.
Yes.
So we don't need to mark anywhere.
No.
Okay, thank you.
Hello.
Yes.
Ma'am, I just want to ask a question. That how we know that the accuracy is good for a model?
Ma'am will join
60%.
after 15 minutes. She's on break. 15-minute break. Okay.